Contrary to the topic of this video, we won't be finding the length of a line, but the length of a segment. This is due to the definition of a line. According to splashlearn.com, a line is defined to be a straight one-dimensional figure that has no thickness and extends endlessly in both directions. So a line would be this, where there's a series of points connecting to each other and goes endlessly in both directions. So if it was diagonal, it would go something like this, and the arrows at both ends means that it goes endlessly in both directions. So this is what a line is like. But what we are going to find in this video is actually a section of this line. So from this point here to this point here, and we will be given coordinates, and we will use those coordinates to find the length of that line segment there. The reason why I used length of a line for the topic of this video is that this is what it is called in some books. So you might hear me saying length of a line throughout this video, but you will understand what is meant by that. So we are finding the length of line segments. So let's look on some examples. Before I go into any examples, I want to write the formula. So the formula is given by D is equal to, and you can put whatever you want here. Some books use D, some books write length of a line, and you can put any variable there that you want. But some books use D. So D, which is the length of the line, or length of the line segment, is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. When we evaluate what is under the square root and we find the square root of whatever we get, then we find the length of the line. So look at this example. Graphically, this would look something like this. So this white line here is what we are going to find the length of. So remember from the formula, D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So our x2 is 5 minus our x1, which is negative 3. All of this is squared, plus our y1, which is 4, minus our y2, which is also 4. All of that is squared. Minus gives us a plus, so this would be 8 and we square it, plus 4 minus 4 is 0 and we square that. Now 8 times 8 is 64, so we have 64 plus 0 under the square root, and when we find the square root of 64 we get 8. So the length of our line is 8 units. And if we look on our graph, we can see that it is 8 units. So we are at this point and we're going to this point. So this would be our first unit, second unit, from here to here, third unit, fourth unit, fifth unit, sixth unit, seventh unit, and our 8th unit. So we can see graphically as well as with the equation that we got 8 units for the length of our line. And this is how you find the length of a line using this equation. For our next example, we have this question. We are supposed to find the distance between these 2 points. So graphically, we would have this. Again, graphically, this is what our line segment looks like. So our equation d equal the square root of x2 minus x1 all squared plus y2 minus y1 all squared. In this example, our x2 would be 1 minus our x1, which would be negative 4. All of this is squared plus our y2. y2 in this example would be negative 4 and y1 would be 5. So minus 5. And that's also squared. Now when we simplify what's under the square root, we have 5 squared plus negative 9 squared. Five squared would be 25 plus 9 squared would be 81. When we add these, we get the square root of 106. The square root of 106 is equal to 10.29. So the length of our line would be equal to this value here, units, whatever units our graph is in. This would be 296. For our next example. So this is our question. This would look like this. So we'd find the length of this line just the same. D is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. x2 would be 2, x1 would be negative 4. And remember, this is under square root. Plus y2, which is equal to 9 minus y1, which is equal to 7. This is squared. This is squared. 2 minus minus 4 would be 6, and when we square that, we would get 36 plus 9 minus 7, and we square that, we get 4. When we add 36 and 4, we get 40, and we find the square root of 40, and we get 6.325 units. So this is the length of this white line here. Onto our final example. The point 8, 2 lies on a circle. What is the length of the radius of this circle if the center is located at 5, 7? So let's draw this graphically. So obviously this is not drawn to scale, but this is where the center of the circle is, and this is where it touches the circle. So we're going to find the length of this white line there. So let's do that. We will attempt this using the same formula. D is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. x2 is equal to 8 and x1 is equal to 5, and we square this, plus y2 is equal to 2 and y1 is equal to 7, and we square that. Eight minus 5 is 3. When we square that, we have 9. plus 2 minus 7 is negative 5. When we square that, we get a positive 25. When we add what's under the square root, we get 34, which is equal to 5.831 units. And that's the length of this white line here. So that's it for this video, and this is how you find the length of a line, or more accurately, the length of a segment. So thank you guys for watching.